Greetings everyone. Today's episode we're going to be trying to make pyridine from niacin in what is a fairly established reaction, and it's kind of already been done to a certain extent on YouTube. Both Doug and Niall Red have a video on this topic, and it's not really much experimental at the moment. What I'm going to do, we're basically going to be following the kind of established procedure is what I'm saying. So to do the reaction, we have to take niacin, which I haven't got yet. I'm going to get it in the mail in a couple of days, I hope. And you need to decarboxylate it. So we've got to rip off a CO2 group from that pyridine ring, and that will free our pyridine. And you need a catalyst for it. In Niall Red's video, he uses basic copper carbonate, which is I have some here from like possibly 5-6 years ago, back when I was my mum's a nurse, so she used to be able to get me like these urine sample tubes. Obviously sterile, but they were very useful back in the day. Some of my really old chemicals are still stored in these piss pots. But anyway, when you use the basic copper carbonate as a catalyst, you get yields from niacin of about 40s, like 40 to 50% yield. What you can do instead is you can make a catalyst, a copper chromite catalyst, and that's a lot better catalyst, and you get yields in from the 80s to 90s. Basic copper carbonate is very easy to make, and of course I have some on hand, but putting in the extra effort now to make the catalyst doubles our yield later on, which is useful for me because the niacin I only got 250 grams. It was a little pricey just because it didn't seem that very available in Australia. Doubling our yield seems worth it, especially because the decarboxylation and distillation is also quite involved. So I have 23 grams of copper sulfate here, and we're going to dissolve it up, and then we need to add some ammonium chromate to it. And what I have here is some waste hexavalent chromium from the 12th of January 2016, according to its label. We're going to get some of this and just basify it with some ammonia. And obviously we're not caring about stoichiometry because I just put a random amount of this chromic acid in, and that's just because we're just going to form an insoluble precipitate, and hopefully the copper's in excess, so I can just add this until we've used up all the copper. There we go. So we have some precipitate collecting at the bottom here, but it is definitely the wrong colour. It is bright green, and we should hopefully be seeing some red stuff. So that tells me we don't quite have enough chromium in here. So we're going to try, and there are hints of it, like here, that's the right colour, that sort of thing. So we're just going to try and add some more chromic acid. Hopefully that kicks it into gear a little bit better. Alright, amazingly it is actually working. But we can see as all the red stuff settles that it's really green up the top here. So I think there's still heaps of copper left in terms of how much chromium versus how much copper is in there. Alright, I've cooled it down. So now it's time to filter. I really don't think there's much in here. I think I really stuffed this up already, but I can always delete the footage if it doesn't work. Alright, as I suspected, there really wasn't that much in that solution, and it took over 4 hours to filter. Probably, just on 4 hours. Yes, I'm just going to heat it on the hot plate to dry it out. Alright, that was pretty easy, pretty quick to dry it. Dried pretty well. And now the next step is we want it to kind of decompose it to the copper chromite, and we need to do that at like 400 degrees or so. So we're going to go over here. Where is it? There. We have a soup can. I think it makes a pretty reasonable crucible. And here's our product before the
the heat treatment. A little bit more darker than iron oxide. If I saw that, I'd say it was iron oxide, but you know, looking at it now, it's probably a little bit darker. So, all right, so I've got my infrared thermometer here, which is reading it as 13.6 or so. And then we've got a thermocouple probe in the actual solid itself in there. So, and that's reading 18.4, if you can read that back there. We've got a bit of the readout on the temperature. As far as actual temperature control goes, I'm not sure how well this will do, but at least we can see when we're going wrong, I guess. Alright, it's had 10 minutes of between 300 and 400 degrees, at times getting just a little bit over 400. So I think that's good. We'll let everything cool down and then have a look, see what we're dealing with. Alright, let's do it. Oh, that looks fucking mint as. Beautiful. Alright, let's get it out of there, let's weigh it. Okay, I actually completely forgot about a step, and that's where we wash the solid with a bit of water and, like, you know, acetic acid or some sort of weak acid, which is going to remove the copper oxide and just leave us with the copper chromite. But we're going to compromise and just not do that step at all, because I've already bottled it and I don't actually have any acetic acid on hand. So we're going to see how it works without the washing step. I have a feeling it won't matter too much. You know, it'll save us quite a bit of time by not doing that step, because there's a whole filtration we have to do and another drying step, which isn't too hard, but it's just time. So we're just not going to do that. And we have a yield here of 8.2 grams, which I think is pretty good. Purity is pretty low, but we'll just get around that by just using a slightly higher catalyst loading. Grandma now gives me all her empty pill bottles to store chemicals in, even though a lot of them are completely the wrong size. But, you know, I appreciate the support. Alright, so this is our niacin in this bag here, so it feels pretty fine. The Science Madness post that we're following uses 60 grams of the niacin and 1 gram of the copper chromite catalyst. We're going to change that up a little bit because we didn't wash the copper oxide out of the chromite catalyst. We're going to change it up to, let's say, 2 grams. The amount doesn't really matter, but we just want a nice mix of the two, and 2 grams will be better anyway. More to play with then. And also, from the look of those pictures in the 500ml flask, it looks like we could possibly sneak another 10 grams of niacin in there. So we'll put 70 grams of niacin with 2 grams of catalyst. So I'll just weigh that out now. I get the pleasure of opening a brand new packet of chemicals. Oh yeah, beautiful. Alright, so this is half of the niacin we need. It's 45 grams, so yeah, it is quite a lot. And actually, we're going to just here straight off make the same mistake that Noel Red did, and we're going to just try and mix it all in a mortar and pestle first. I know this is really fine, but this is in some lumps, so actually we'll weigh out the 2 grams, crush it up first, and then mix it with this first half, and then we can mix, you know, this half with the other half, if that doesn't make any sense, but we'll just do it. So we're left with this even grey powder here. I think I could have done a lot better with crushing up the chromite catalyst initially, because you can sort of see some black flecks through it, which is kind of a bit of a wasted catalyst. But overall, I think it's fairly good. So we're now going to try and get it into the flask without spilling. The flask is a little dirty. You can see it's quite stained, but that won't make a difference in the slightest, and it'll stop me wasting time just cleaning it. Alright, so we have our mixture here, and now we just have to set up for distillation. I'm so confident in I don't think anything will actually go wrong with this distillation, it won't be that hard, that I am willing to set it up and let it run in the dark. I'm still going to monitor it. I'll set up some lights, but yeah, it's getting very late, but you know, I don't really have much free time. It's going to be shit filming, but you know, at least it'll get done. Alright, I overshot the mark slightly, as in I was heating it, and we've just got a little bit of our white substance. Ooh, what is that? Niacin distilling over, so that'll contaminate our product, but we have to re-distill anyway, so I'm not too concerned about it. Alright, good news. I can tell it's working because all of a sudden it started to just fucking reek. We've got a little bit of liquid over it. You can see it's heavily contaminated, but like I said, we're doing another distillation. We should be alright. Thick, fishy aroma to it that you just, it's not a very chemical smell. It's a real rotten food kind of smell. It's real bad. But once again, it's the smell of success. So we're running into a slight problem where the solid seems to sublime quite easily, so it's kind of filling the top of the flask there. It's not clogging it because it's quite loosely packed. It is stopping it sort of reacting, because if I took away the heating mantle, that there'd be hardly any crystals along the bottom, and they've all just kind of sublimed and it ended up here. So I'm just going to get the blowtorch, because I don't think like a hairdryer is going to be hot enough, because it's already pretty hot, but it's all just sitting on there. If I blowtorch it really lightly, I should be able to melt this stuff around the top down. And that should fix the issue for now. And as it keeps reacting, it'll be less and less of an issue, but yeah. Yeah, knocking that stuff back down into the bottom of the flask really does help. You can see the pyridine rate coming over now is quite a bit more substantial. So the drop every couple of seconds, which is a lot better than it was. But getting to near the end of what's actually left in the flask there. So yeah, I was right in assuming that there really wasn't much actually at the bottom of the flask. Alright, it's definitely done. That little black stuff at the bottom is basically just our catalyst. Unfortunately, it did get a little yellow at the end of it, so I'm fairly sure we overheated it, and it didn't really help with the blowtorch and blowtorching back down, but you can see it, the yellowing kind of caused the yellowing of the liquid coming over there. And I'm using the gas mask. I haven't actually mentioned that much, but not just because it smells awful, but because pyridine really isn't very healthy to breathe whenever I'm not having to talk on camera, been breathing through the gas mask, so I really haven't been exposed hardly at all to the pyridine. Hopefully I can continue that. Now we're back in some daylight, we can see that there's quite a bit of niacin that came over. Now everything's cool, the niacin kind of precipitates out. I think I did just get a little bit too excited with the heating, especially with the blowtorch around the side that kind of drove over quite a bit of niacin. We can chemically clean that up. We just got to add some sodium hydroxide to it, and that will lower the vapor pressure of the niacin by turning it into a salt. Yeah, and then that won't come over with the second distillation at all. So that'll be fine. Really not too much of an issue. It's just a lowering of the yield issue. Alright, the distillation is complete and we have quite a bit of solid left in the flask. It's obviously just losses to our yield. It's obviously just niacin that's come over in the first distillation of the pyridine. None of it really, it looks like it's been splashed around, but it hasn't really looked like it's been sublimed up in the flask. The re-distilled batch of pyridine should really be free of any niacin, which is good. Alright, and here's our final yield. 28.2 grams represents a percentage yield of 63% based on the 70 grams of niacin we put in there. If you remember at the start of the video, we discussed how if we used basic copper carbonate, we'd get a yield between 40 or 50. But if we used our, high-tech copper chromite catalyst, we should be getting yields in the mid-90s, I guess. Well, we got neither of them. But of course, as I've mentioned a few times, that lowering of the yield really is because of that niacin that we put over, because we just overheated it a bit too much. There was that thought about maybe copper oxide would perhaps destroy some of the pyridine. It's hard to say if that actually had an effect or not. I was really thinking it wouldn't, but the fact that we're getting, less than 70% yield, looking at the amount of niacin that we actually had during the second distillation, the amount of niacin that crashed out of the pyridine, it's hard to sort of pin a 20% loss of yield on just that amount of niacin. So perhaps it did have some effect, but there's also other issues like, our collection efficiency, whether we actually managed to condense all it down or any evaporated off or that sort of thing, and mechanical losses. But all of them are quite small, especially seeing as pyridine has a boiling point of 115, so not much kind of boils off at room temperature. And it's quite a good jar, it seals it quite well, so I don't have to deal with smelling it unless I intentionally open it and force people to smell it.
Anchovies?
Anchovies.
Yeah. It's not good.
It's not good.
It's like olives and anchovies. And
It's pretty gross, isn't it?
it's like bad.
It's real bad. I hope you enjoyed this video, how we got a fairly obscure, toxic, foul-smelling substance out of a vitamin. It's another one of these great examples of how you can turn an everyday sort of chemical, into something that's a real laboratory chemical. Yep. See you next time.